Okay, so we're going to go right back to where we started, just to remind you of the topics that are going to appear in the first test on differentiation. So that test again is Tuesday. And we went all the way back to the definition of derivative. That's where we started. So for the first one, I'll show you both definitions that we talked about. What I want to do is I want to just give you an idea where they come from again. So for example, the first definition of derivative we talked about, if there's a graph like this, and let's just say that this is the point x, and this is some distance away that we call delta x, then the position I'm at now is x plus delta x, and this is a secant line, a line that has 2 points. Okay. As delta x approaches 0, so it starts to move its way along, it gets me a better and better approximation for the tangent line until it in fact is the line that's tangent right there at the graph. Okay? So if I was to tell you what these values are, this is the value f of x, this is the value f of x plus delta x. So I just need the slope formula. That's where it comes from. Remember, a derivative is the slope of the tangent. So the slope formula would say f of x plus delta x, take away f of x, and then on the bottom it would be x plus delta x, take away x. So these pieces would be gone, and I'd end up with f of x plus delta x, take away f of x over delta x. And of course, that's the slope for 2 points. In calculus, we're interested in the tangent, where it's just at 1 point. That's why we need a limit as delta x goes to 0. We couldn't divide by 0, right? It won't work. But as we approach 0, it's going to approach the value for the tangent line. So that's our first definition. Let's take a look at how we get the derivative by definition for this. Okay, so to set this one up, it's the limit as delta x goes to 0. So the function at x plus delta x is going to be 3 times x plus delta x all squared plus 1. Take away 3x squared plus 1. And of course, this is all divided by delta x. So I'm going to give you a minute. I'll leave you to it. See if you remember how to simplify this and actually show that with the definition, its derivative, which hopefully we all know by now is 6x. See if you can figure out how that works using this, and we'll recap together. Okay, so I know some of you are still writing, just getting to the end of it. I'm going to try to catch up to you, so you can double check your work against mine as we finish this off. So I know this process was not your favorite process, and we've spent the rest of the unit getting away from there, but I can't stress enough to you that it's going to appear. It'll be somewhere in your AP exam, somewhere in your unit test. It'll still show up in Barron's. It's important that you know where that definition comes from, okay? So, questions about that one? Hands up if this is, you're able to do this definition, it worked for you. Good, okay. Good to know that we still remember them. I'm going to show you the alternate definition for the second one, which was, I'll show you the picture of it as well to make some sense of it. It's very, very similar to the one that... This time we're going to take a look at 2 points. So it goes like this. This time somebody using limits might say, okay, maybe this time I want the derivative at some point, and I'm going to call that point C. And I'm going to start at some point x, and I'm going to move x until it's right over top of C. So this would be the secant line. And then as I move closer, it starts to approximate better and better until it in fact is the tangent line. So this would be the same slope formula. It's just I'm using two distinct points, not some change away from x. So the slope formula would be f of x minus f of c over x minus c. And that's 2 points. So remember, in calculus, we're interested in the tangent, which is 1 point. That's why we want a limit as x goes to c, which will make it the slope at a single point, the tangent point. Okay, so that was the second definition that we talked about. And we'll do the square root one definition that's on your notes using this alternate definition. Okay, so I'll let you try and work that out, and then we'll recap again together. Okay, so it looks like there's some mixed reviews here. If you set it up right, then I'm taking a look at the function at both x and c. So it would be the limit as x goes to c of square root x minus 5 minus square root c minus 5, all divided by x minus c.
Yes.
So again, this definition is saying let's take the 2-point slope formula and we'll move one of the points until it overlaps. So now we have 1 point, the slope at 1 point. Okay, do you remember what technique we did here when we were working with limits?
Conjugate?
Yeah, the conjugate's the one you want to work with. So root x minus 5 plus root c minus 5. And of course, we have to do the same thing to the bottom in order to keep these two things equal. So if I multiply these out, you're going to see the difference of squares pattern. So it's now going to be the limit as x goes to c. If I square that square root, it'll just be x minus 5 and c minus 5. And on the bottom, there's no point in distributing these, so I'm just going to leave them factored. Okay. So if I collect my like terms, what's going to happen here is this is the thing causing the problem, because that makes it divide by 0. But fortunately, that minus 5 take away minus 5 will disappear, and I'll end up getting this thing to factor out. It would be the limit as x goes to c of x minus c over x minus c. Sorry, that's a 5, that's not a c. Try that again. X minus c, x minus 5 plus c minus 5. So that means I'll be able to take those factors out. And now I have no more issue with dividing by 0. It's possible to evaluate this limit. This would be, as x goes to c, this turns into a c. So I end up with root c minus 5 plus root c minus 5. Add them together. This is probably the one that you would have come up with had you used the chain rule on it. Yeah, so remember, we're moving x onto that point c. That's why the derivative has the answer at c. Even though it's a c, you'd now be able to tell me, well, what if I want at 2? Well, then put in c equals 2. What if I want it at 5? Put it in at c equals 5. Okay? So I'm not going to focus too much on your definition, but I do expect you to know it, so be prepared to see it on Tuesday. Okay, then we went into that wonderful world of shortcuts that we will talk about for the rest of the lesson. So let's see, at this point, if you're comfortable with your shortcuts, it should take you maybe 2 minutes to do these 3 questions. So see how you do. We'll give you 2 minutes and see if you're about there. Pretty quick with them. All right, so for the first one, This one's just power rule stuff, so hopefully this one didn't trip anybody up. The second one, I would probably rewrite this. First of all, I would probably go and remove that chain rule. Now I don't have to deal with the chain rule question. And that was pretty easy. That was easier than doing a chain rule, I think. And then I would probably write this so that I could just use the power rule. Probably the easiest of all the rules we've seen. So this would then become negative 10 over 4 x to the negative 3, or negative 5 over 4 x cubed. Sorry, that should be a 2.
So you don't move the 4 out, you only move the x squared up, right?
Say again?
You don't move the 4 up?
Well, I could move that 4. I think you're talking about this 4 here, right?
Yeah.
I could move the 4 up, but then I would also have to take its reciprocal, right? Because this went from x squared to x negative 2, right? So it went from a positive 2 to a negative 2. That's why I was able to bring it up. If I wanted to move the 4 up, it would be 4 to the negative 1, or a quarter. It's not useful usually to move the numbers. It's usually the letters that'll help us use the power rule. Okay, and then finally this piece here, 3 over 5 cos x minus 2 e to the x. So then what I'm going to do for you is I'm going to start these next couple of questions and then I'll have you do the rest. So for example, these are product and quotient rule questions. Let's try a product rule together. We'll try a quotient rule together, and then I'll see how you do with your neighbors. So if this is the first one I start with, it's going to be each one gets a turn as the derivative. So for example, it'll be 3x squared minus 3 times x plus 2 plus the derivative for x plus 2 will just be 1, and x cubed minus 3x. So again, you can go ahead and simplify it if you'd like to. I'll show you 1 or 2 of these today to simplify just to give you some ideas. But I'm more concerned that you can do the calculus part of it. We'll try quotient rules as well together. So let's do this one for quotient rule. So quotient rule will be derivative of the top divided by, derivative of the top, so 6 times the bottom, subtract the top times the derivative of the bottom. And it's all divided by the bottom squared. So I would like you to try those next 4 questions. There's 2 product, 2 quotient. And then we'll see how you did. Have a chance to compare it with your neighbor and make sure you agree. And we'll see how everybody did in just a minute. Okay, so I think it looked like people were getting the product rule questions done. So for the first one here, it's going to be the derivative of the first piece times the second piece plus derivative of the second times the first. So I mean, I guess I could at least rewrite it like this. And then for the last piece, there is no product rule in this first part right here. Nothing to worry about. But I'm going to call it just 2. This piece, however, does have product rule. So I'm going to be taking away derivative of the first piece times the second plus first times the derivative of the second. So that subtraction affects both pieces. So your answer should be subtracting both of those.